In this example, we're going to go through a probability problem that uses Bayes' theorem. It's also about conditional probability, or you can think about it as reverse conditioning. So in this example, it says that a website reports that 70% of its users are from outside a certain country. Of the users from the country, 5/11ths log on every day. Of the users from other countries, 2/7ths log on every day. And what we want to know is what's the probability that a user is from the country given that he logs on to the website every day. So there's some clues to this problem that help me figure out what I'm going to do. First one here is the question is saying find a probability that something is true, that a user is from a country, given that they log on to the website daily. So that word given is the clue for conditional probability. Before the word given is what I want to find, and then after the word given is what needs to be true in the first place. And then up here in the earlier part of the problem, it gives us a fact. 70% of the users are from outside a country. So 70% are outside of a country. And then there's that word of. It says of the users from that country, 5/11ths log on every day. Now, if you remember from algebra class, when you see the word of, it means multiply. So we're talking about a percent of a percent. So first we need to figure out what percent are users from the country, and then it's 5/11ths of them that log on every day. Then the next sentence also has an of the users from outside the country, 2/7ths log on every day. So there's some conditional probabilities here. First, we have to know if you're inside or outside of the country. And then after we know that, it says that 5/11ths log on every day or 2/7ths log on every day. So when you see conditions like this, a good place to start is with a tree diagram. So you start with a node and then we draw two branches. So the probability that's just a straight out probability, it doesn't have the word of in the sentence, it's just, hey, this is a fact. That's the 70%. 70% are people from outside of a certain country. So I'm just going to say the probability from being outside a certain country is 0.7. And anytime we have two branches like this, or maybe it's three branches, or maybe it's four, whatever comes out of this node, the total has to be 100%. So this is why we weren't given anything about people from inside of the country, because if you're inside the country, that's opposite of outside the country. So it's the complement. The probability of being inside the country is equal to 0.30. You could also write it as the probability of being outside the country complement. That's also equal to 0.30. But I'm just going to stick with using two different event labels instead of saying like A and A complement. It's a little bit more understandable for right now. So on to the next branch. Now that we know if someone's outside the country or inside the country, it gives us the next fact about are you logging on every day, yes or no. So each branch will have its own split off again. So of the users from the country, okay, so now I know where to look. If you're inside the country, 5/11ths log on every day. So the probability that you are logging on daily to this website is 5/11ths. 5/11ths. The next sentence says of the users from other countries, so that means we're looking, outside of the country. Of the users from other countries, 2/7ths log on every day. So here, this branch, the probability of logging on daily is now 2/7ths. So make sure to read the words really carefully. Read which is a conditional probability and which isn't. These ones in blue are the conditional probabilities. It says if you came from this branch, now the probability is such and such along this branch. So what about these other branches? Those facts weren't given to us, kind of like the 30% wasn't given to us. We just know that the total has to be 100%. So if I wanted to keep on going, I could say the probability of daily complement just seems a little bit easier than trying to figure out what's the opposite of daily. Not daily. That's a lot of words to write down. I would write 5/7. And then the same thing right here, the probability of not logging on daily, so daily complement, the complement of 5/11, that would be 6/11. Now we actually don't need to use these numbers here in orange. I just put it in there for completeness. So at this point, let's look at the real question. What's the probability that a user is from the country given that he logs on every day? So what this means in symbols or in probability notation is what's the probability that they are from the country? So I'm going to say in the country given, that's the symbol for given, that little vertical line, given that they log on to the website daily. So we need to know this. That's what we're trying to figure out. So this is actually backwards because remember when we put down these 2/7 and 5/11? The phrasing was, if you're outside the country, here's the chance you're going to log on daily. The question we are trying to answer is, what's the probability that you're in the country given that you're logging in daily? So in a tree diagram like this, whatever comes in this first branch right here, let's highlight it a little bit. This guy here, this is what is given because it's the starting point and you have to know what branch you're on first before you can move on to the second stage. So it's the inside of the country or outside of the country that is given, and then you figure out the probability that someone logs on daily. This question is just backwards. We are given that we're logging in daily, so that's like these branches, and now we're trying to backtrack and figure out, well, what's the chance that you're inside the country? So to do this, we could keep working with this tree diagram, but I actually find that instead of using the Bayes formula that's given in the textbook, I find it easier to make a table to figure out this conditional probability. So bear with me while we write out these probabilities in a different way. So I'm going to start with a contingency table. So contingency tables, we talked about them in earlier chapters of the textbook. And in probability, it's really easy to compute conditional probabilities with a table. And that's what we have here, a conditional probability. So in this table, I'm going to label my rows and columns. So the first, back up here, the first quality was, is the person outside of the country or inside the country? So there we go. And the columns I'm going to label as daily and then not daily. So how often the person is checking that website. All right. So the very first fact we were given is that 70% of users of this website were from outside of the country. So 70% is the 0.70, but bear with me while I just turn it into a 70. So if I pretend I have 100 people, so here's 100 people, 70 people are from outside of the country. So I didn't fill in the blanks here in the squares because these squares overlap, daily and outside of the country. Here's the square for not daily and outside of the country. If I put a total, this is a marginal total, it says, hey, everybody that's in this row, it adds up to 70, whether they log on daily or not, but 70 people are outside of the country. So then you can figure out, well, how many people are inside the country? And just like I used a complement, 100% minus 70%, 1 minus 0.7 gave me 30%. I can pretend that 30 people are inside the country. And by pretend, I mean, I'm taking 100 people as a basis. I'm not using percents. I find that these integers are a little easier to work with than all these decimals. It seems a little bit more lifelike. So, okay, we have 70 people outside of the country and 30 people are from inside the country. Now, the next facts. So go back up here to our tree diagram. It said that if you're outside of the country, the chances that you log on daily were 2/7. So outside of the country and logging in daily, 2/7 of those people logged in daily. So I'm just going to put that 2/7 right here for a second. I'm going to come back and figure out how many people were logging on daily. And then similarly, if you're inside the country, the chances of logging on daily were 5/11. So I'm going to put a 5/11 right here. Just a little reminder for me to do my math later. Okay, so in all, we have 70 people outside the country. If 2/7 are logging on daily, I just need to find 2/7 of 70. So 2/7 of 70, do the multiplication, that ends up with 20 people. So 2/7 of 70 is 20 people. 20 people out of 70 are logging on daily when you're outside of the country. So you can see how 20 divided by 70 makes 2/7. Now let's do the same thing with 5/11. 5/11 of everyone else, so of the 30 people, are logging on daily. And I'm going to round this out to 13.64 people. Okay, so it's 5/11 of the 30. Now I'm going to scoot back up here to the tree diagram. You can multiply numbers along the tree diagram and get a probability, like an and probability. What are the chances that you're in the country and logging on daily? You just multiply those numbers together. And that's kind of what we did right here. We were multiplying, well, it wasn't a probability, it was a count, but it's the same idea. So I'm almost done here. I notice I have a couple of blanks to fill in, and I'm just going to go ahead and do some math and fill in the rest of the table, just for completeness. So if I want to find this marginal total, how many people are logging on daily, if I had a hypothetical 100. So 20 and 13, so that'll be 33.64. Now let's figure out this spot. 20 plus what makes 70? That's 50. 13 plus what makes 30? That's 16.36. And then I can find this other marginal total. 50 plus the 16, so that's 66.36. And you'll notice that when I add up 33 plus the 66, I get 100 people. So I've just categorized the people different ways. Okay, once I have my table filled out, now I can answer my conditional probability question. So I can finally answer this question up here, the ultimate question of the problem. What's the probability that someone is in the country given that they log on daily? So the given is that someone logs on daily. So I'm going to write this again down here. The probability that someone is in the country given that they log on daily. So a conditional probability is just a part out of a whole. So the given is what we look at first. So I go back up here and say, well, what's the number of people that log on daily? So that is 33.64 are logging on daily. And then the question is, now out of the people who are logging on daily, how many people are in the country? So I'm really just focusing my attention on this column because these are the people that are logging on daily. I can ignore everything else in that table. It doesn't matter. When you condition, you are like putting on blinders and you're only looking at one specific column or maybe one specific row at a time. So I'm looking at the column that is logging on daily, and now I have two choices. Someone's either inside of the country or outside. I want to know the chances of someone being inside the country. So we have 13.64 people inside the country. So I have the part out of the whole, the people who met the condition, out of our total here. So now I'll divide 13.64 divided by 33.64, and I get 0.41 when I round. So this is our answer right here, 0.41. So the probability that someone's in the country, given that they log on daily, is 41%. So I hope that helps with Bayes' theorem or reverse conditioning. You can start with a tree diagram. There are ways to continue with the tree diagram to get the answer though. But I kind of find that using a table makes a little bit more sense because I can really focus in on the column that makes sense and then the quality that makes sense and just do a little bit of division.